Hi, everyone. Welcome. I'm Ruth Linehan, and this is Nathaniel Smith. We're both back-end services developers at Puppet Labs, which is an IT automation and configuration company here in Portland. We're here to talk to you about TrapperKeeper, which is a service framework that we wrote and use at Puppet Labs. We'll both give a brief introduction and overview, and then Nathaniel is going to talk about TrapperKeeper RPC, which is a library that he wrote. So what, in fact, is TrapperKeeper? As I said, TrapperKeeper is a service framework for long-running applications. So service framework is a pretty generic term, and I'll go into a bit more detail of what we mean by that in a minute, but really it's just a binder for modular bits of code. It's written in Clojure. We're at Clojure West, obviously, so hopefully it's written in Clojure. And it's the basis for all of our back-end services development at Puppet Labs. It's also open source. You can check out its GitHub repository in the Puppet Labs namespace. We've had some great community contributions recently. Dylan is one. It's been great to see, and we'd love to see more people contribute to it and check it out. So last year at Clojure West in San Francisco, I think PuppetDB, which is our service for storing Puppet-related data, was called out as one of the most deployed Clojure applications. So we at Puppet Labs have had a lot of success with Clojure, starting with PuppetDB, and we wanted to expand that to more products, to more services. And so in doing that, we wanted to take the lessons that we had learned from PuppetDB and be able to kind of extract them out and reuse some of those things. So we wanted to make sure we weren't reinventing the wheel with every single application we had, and that we could easily reuse code across our different products. So in the past year, we've released several more Clojure products built on TrapperKeeper, and we've moved PuppetDB to be now using TrapperKeeper. So these include Puppet Server, which is also open source. It's our Puppet Master written in Clojure, and a number of our commercial products are now written in Clojure. So more specifically, what's a service framework? What does it give us? One thing is, as I've mentioned, we really wanted it for code generalization and component reuse, being able to take one piece of code, like what is used to set up a web server, and use it across multiple different products. Frequently, so we call these things services, these bits of code that we have. And the reason that we want a service rather than just a library of functions that we can use in different places is that typically a service is something that has to manage state. And with that comes, it usually has a life cycle. So something has to happen when the service is initialized. Something is then going to happen when it's started, and when it's shut down. And so with each of those stages of the application, we need to manage some state and do it in a consistent way. And typically, our services have dependencies between themselves, or amongst themselves. And so we want to make sure that we have managed those dependencies, that and that we're starting and stopping the application in a way that all of those dependencies will work together and we won't break anything. So why TrapperKeeper? There are a bunch of other frameworks that do similar things as this. A lot of what I've talked about is really influenced by Stuart Sierra's Clojure Reloaded framework, or pattern. And so, this is pretty similar to things like Component and Jig. There's also things like Immutant. We've borrowed some from OSGI as well. So there's a number of other things in this space that do something similar. And for us, the real reason why we wrote our own thing was that we ship on-premise software, which means that the service framework that we use is part of the shipping application. It's something that our users are going to be interacting with. And so, first of all, it needs to be lightweight. Because of the way that we package and ship things, we can't be easily shipping something like JBoss. We also don't always need a web server in the specific application we're shipping. Some things need a web server, some don't. We don't always want to be shipping that. And we want our users to be able to configure it easily. Once they've installed it, they shouldn't need to know Clojure in order to tune it. So a lot of our users, most of our users are system administrators who don't really have experience with Clojure and don't really want to learn it to have to tune Puppet Enterprise or Puppet. So TrapperKeeper provides a lot of features for being able to configure it very easily from config files. So some specific features of TrapperKeeper, other than kind of what I laid out for what we consider a service framework, are the ability to turn services on and off just via a config file after we've actually deployed, or being able to swap out which implementation of a service is used via a config file. We also sometimes want to be able to run multiple web applications on a single web server. So for demo purposes or for setting up a test environment, our users might want to just kind of deploy everything on one node and test it out. And then to actually have an environment, a production environment, they want to split these applications out onto multiple nodes for performance. And that can be achieved with just some changes to a config file. We also really wanted unified logging and configuration. So TrapperKeeper sets up a logging system for you using Logback, and all services can be configured in the same way just by changing around the Logback file, XML file. And as well, configuration and handling config files. So we want to be able to not have to kind of rewrite how we do config files for every single service. We want that to be consistent across all of our applications. So TrapperKeeper also has some existing services that anyone can use. There's a config service, which is built into the main TrapperKeeper library, and that's used for parsing config files. There's a web server service, and this is outside of the main TrapperKeeper library. It's something you can use if you want, that allows you to easily add a ring handler or a servlet to easily set up a web application. We also have built-in an nREPL service, which is really useful for debugging. And what we'll talk about in a little while is the RPC server service, which Nathaniel wrote. So to illustrate a little bit more some of these features of TrapperKeeper, we're going to be using a demo application that we wrote. You can check out the code at Puppet Labs TrapperKeeper demo on GitHub. It runs a web server with a ring application, which responds meow to a caller in the URL in different languages. So it's a just pretty simple demo application with cats, because cats are great. So this is what kind of the core functions of our application look like. We have a cat say, which is an ASCII cat, and then a French meow, an English meow, a Japanese meow, which pull in from a database kind of how to say meow in that language and respond with meow and whatever the caller is from the URL. So let's talk about what makes up a service. The first thing that you have for a service is a protocol that specifies the API contract that service is going to have. And you have the functions that implement that protocol. You have the life cycle of the service. Again, what happens when it's initialized, when it's started, when it's stopped. You have the config for that service, typically what it pulls in from a config file, as well as the config that says what services to actually run. And then you have a service context, which is a way for a service to store an access state rather than having it be globally defined. So each service has its own context, which means that you're not having this kind of global state everywhere. So protocols define an API contract, and you can have any number of implementations of that contract. And then Trapper Keeper allows you to, through a config file, select different implementations of that contract, of that protocol at runtime. So for us, our protocol defining our meow service is just a single function that takes a caller. So the first implementation of our meow service, and it is an English meow service. So we're going to have multiple implementations of our meow service in different languages of meowing. This is a really contrived example. You probably wouldn't write a service that is saying how to meow as a cat. But just for the purposes of this talk. But a better example might be, as I talked about our web server service, we have a Jetty 9 implementation of it, and we have a Jetty 7 implementation of it. And you can easily use either of those by just changing a config file. We could also conceivably have a Tomcat implementation of a web server service. We don't yet, but there's no reason why not to, so long as it fulfilled that contract specified in the protocol. So in this example, you can see we define with the Trapper Keeper def service a meow English service. It implements the meow service protocol. It has an init function, which gets from the config a database path, and it associates that into the service context for use by other functions. And then it has a meow function. So this is its implementation of that meow specified in the protocol. And in this case, it's using the English meow function. Another implementation is the French meow service, which does a similar thing. It specifies an init, so this is one of the lifecycle functions, which can be, you can optionally define that for the service or not. And then again, you have the meow function, in this case, the French meow. So services typically have dependencies on each other. This is what our web service looks like. This is what is actually calling that meow function and adding it to a ring handler to make a web application. And you'll see here that list right below the meow web service, def service, lists the config service, which we use get in config from that, and the web server service, and then the meow service itself. So this is how we specify service dependencies. And what we're actually using is we use Prismatic's graph library, which is part of Prismatic plumbing, to build out a graph of the service dependencies. And then we call those in order. So you'll see here we have specified an init and a start for this function. And because this function depends on the config service, and then the web server service and the meow service, all of the inits for each of those other services will be called before the init for this service. And the same with the start. So that's how we're able to handle the life cycle well and make sure that our application starts up and shuts down correctly. And I should say, we don't have the stop implemented here, and you don't have to, a service doesn't have to implement every single part of the life cycle, but then stop gets called in the reverse order of dependencies. And I'm not sure I said this, but the syntax there for specifying what are the service dependencies is Prismatic Graph's destructuring syntax.
So as Ruth has mentioned a number of times, the configuration is really important in a Trapper Keeper app. It's how you decide what services are going to be included when you start up a Trapper Keeper process, when you start up a JVM. And it also decides what are the configurations of your various services, like host names and ports and file paths and database information, things like that. So we kind of have this notion of there's two different kinds of config files. We've got bootstrap files, which are just lists of services, and then we've got configuration files. So for the configuration files, we support a number of different formats. We've kind of standardized on this format called HOCON, which I was very, suspicious of this at first. It was new and shiny, which are usually terrible things, but it's actually wonderful. It's a superset of JSON. It adds human-friendly features like comments, and just in general has been a really great config format for us. So all of our TrapperKeeper services are configured in Hocon, but you can use JSON, EDN, good old INI files, properties files, and we recently had a community contribution to support YAML. So what a TrapperKeeper does is you can either, when you start up a TrapperKeeper application, either point it at a single config file or at a directory full of config files. And so these files are going to look something like this. They're going to be a series of keys and maps of actual config information. And so all of these various keys will be slurped up from whatever config files TrapperKeeper finds and then merged into one big config map that you can then pull into your service using the configuration service. So here you see we've got some global config, which is setting up some logging. The actual logging config, we just rely on logback XML files. And after that, a web server config. So here we're defining one web server. We could be defining multiple, but here we're just defining one to house our awesome meowing API. And then finally, a config stanza for the actual Meow service. So in this case, our only config information is what I like to call the web scale MeowDB, which is just a flat file that has mappings from language to how you say meow in that language. As Ruth said, this is a pretty contrived example, but the idea here is to show how to kind of do database connection at a higher level and then store that kind of state in a context, as opposed to in a global or reconnecting from more core logic code. So this is the other config file that I mentioned. This is a bootstrap file. So this file is what actually decides what services get picked up and then loaded into your TrapperKeeper app. The order is totally irrelevant here. The actual load order for these services, the order in which init and starts are called, that's all decided on by the dependencies between your services. So these look like kind of they're in order, but they're not. It can be anything. So the syntax here is a fully qualified path to the symbol that contains a reified TrapperKeeper service. So here you'll see we're loading our Meow web service. That's the one that Ruth just showed you. It adds a ring handler to a running Jetty web server. In order to do that, we need the Jetty service. We're choosing to use Jetty 9 here. And then there's also a web routing service. We're not going to go into that, but that just adds a little bit of abstraction on top of the Jetty server itself so that you can do URL routing directly to services in useful ways. And then finally, down at the bottom, here's where we're actually picking what Meow implementation we want. So here we're going to go with Japanese, but we could also activate English or French. So one important distinction to note here is that when we're defining a service, there's kind of two ways to think about it. There's the name of the protocol. For Meow service, it's just Meow service. And then there's the name of an actual reified implementation. So in this file, we're always referring to a specific implementation. But elsewhere, inside of TrapperKeeper, we're usually just referring to the protocol, which we also call the service ID. Because we don't usually care at runtime what implementation you've actually loaded. That's irrelevant. It's literally an implementation detail. We just care about the service ID. So in the Bootstrap file, that's when you really have to pay attention to what your symbols are actually called. So here you see an invocation of line run. So if you're in a TrapperKeeper project, your main function is set to a main provided by TrapperKeeper, which does all of the happy service magic for you. And you can see we're specifying that config file, config.conf, and the bootstrap file. So you'll note with the logging here, things happen in the order that we expect. First, we initialize our kind of core business logic service, Meow service. We see that it's happening in English. Then the web servers come up. And then the Meow web service, which will add handlers to that web service. And then finally, at the end of all that, we get some logging that we can go hit our API and get some cat talk. So there's that in action. So if I go back and edit my Bootstrap config and comment out the line for English Meow, uncomment the line for French Meow, we get cat French instead. So without any change to the code path, we've got this different behavior coming out of our service, or our application rather. So with testing, we definitely recommend writing all of your actual business logic in just normal Clojure functions that maybe accept a database handle that's stored in a context and then passed into your business logic. But the idea is that you're going to be unit testing a lot of that stuff. But it's also a really good idea to do general integration testing on your TrapperKeeper applications. So it would be really tedious if to do that you were starting up and killing a whole JVM just to swap out services or things like that. Moreover, when you're debugging, you don't want to have to do that. So TrapperKeeper provides some great helper utilities in the form of macros to programmatically start and stop TrapperKeeper applications from your test code. You can just have a list of service symbols that you pass in as opposed to a flat file. And you can just write configuration and just as a pure Clojure map and then manipulate that as needed. So here's an example of the kind of integration test I might write. So what this is doing is a normal Clojure test. And what I want to do here is test the behavior of each implementation of Meow service. So I start by making these pairs of sound to service symbol. And I'm going to loop over those pairs. I'm going to start a TrapperKeeper app each time with the different services. So in this instance, I'm only starting up my app with the Meow service. I'm not testing Jetty here. I'm just testing our Meow logic. So you'll note the with macro provided by TrapperKeeper. The first argument is a symbol to which the TrapperKeeper app will actually be bound in the body of your test. And you'll use that to get various bits of information out of the running TrapperKeeper application. The next argument is a list of service symbols. In this case, it's wherever we are in our loop. After that, we have our configuration map. Here, we're only starting up one service, so I only pass a config with a stanza for Meow service. I could specify a different path to a different database or something if I wanted. And then finally, I get a reference to the service via the app symbol that we just made. You'll note that keyword, :Meow service, that's what I referred to as the service ID earlier. So that's how we find the reified service in a running TrapperKeeper app. And then finally, I actually just call the Meow function. So I refer to that Meow function. That's just a regular Clojure function that I pull in. And when I call it, I pass it that reified service as its first argument. So this is just like calling a protocol function with any reified thing. That's definitely what we're doing under the hood. So I loop through each of those. I make sure I get back the sound that I expect, and we're all good.
So if you want to get started and write your own TrapperKeeper application, or you just want to explore TrapperKeeper a little bit more, we have a line TrapperKeeper template. So all you have to do is type line new TrapperKeeper and then a name. And this will set up for you a fully working stubbed application, which sets up a sample web server with routing, and it has a little test suite. It's similar to our TrapperKeeper demo application that we've used. In fact, that was sort of the basis for this demo, added some stuff. But it's a nice way to see how you could set up your own web application using TrapperKeeper and sort of see how dependencies between TrapperKeeper services work. It also provides some REPL utilities for you. And so this is something that's pretty heavily influenced by, again, Stuart Sierra's Clojure Reloaded workflow. And in fact, if you look in the line template and what it gives you in dev users.clj, you notice a lot of similarities to what he kind of published in his blog post. So this gives you the ability to start and stop and inspect TrapperKeeper applications from the REPL, and to do hot code reloading so that you don't have to, when you make some changes to your code, you don't have to restart the entire JVM. You can see those changes much faster. So this is what happens in the REPL if we want to start up our demo application. We just call go, which calls the init and start functions of the service lifecycles. And so you'll see here that we're initializing our Meow service in Japanese and start up the whole application. And we also have some nice utility functions for printing out the context. So that's the service context, where, so in this case, we've stored for the Meow service the kind of database flat file, which just has the how to say meow in French and English and Japanese. So imagine between that slide and this slide, I've gone and changed some things. I've gone and added the Unicode Japanese for the logging. And then I just called reset. And that restarted my TrapperKeeper application without having to shut down the JVM. So I could pretty quickly see what actually changed there. And then I can just call stop to shut down my TrapperKeeper application. So that's kind of our general introduction to TrapperKeeper. I'm going to pass it over to Nate, and he's going to show off the TrapperKeeper RPC library he wrote.
Cool. So one of the original kind of dreams of TrapperKeeper was this notion that we can make these really useful decisions about infrastructure without actually changing any code. We can just do these things from config files. So one of the things that you get with this kind of consistent protocol and different implementations is you can have an implementation of a service that, for all intents and purposes, looks like local code. Functions you're just calling in whatever process you've just started, but is actually using, say, like HTTP under the hood to call out to some other TrapperKeeper service somewhere else on a different host, and then getting results back. And you could swap out kind of this local and this remote implementation as desired. So the example that we're going to look through here is taking our Meow web service, and we're going to offload the computational overhead of actually meowing, which, if it's as hard as most cats make any action seem, that's pretty hard. So we're gonna run our actual Meow service in a different JVM, but we're going to keep our HTTP server on the JVM. Well, I guess they're all new on another JVM. And so to make this easy, I wrote this library that provides a couple of things to automate a lot of that. So the TrapperKeeper RPC library, it provides two things. It provides an actual TrapperKeeper service that starts up an RPC server. So this server, it's currently just HTTP based. And you configure it by saying, like, here's where my code lives. And then it knows how to, when it gets a request for an RPC call, look up the definition for that code, call it, and then ship the result back. The library also provides a macro for automatically generating an RPC-ified implementation of an existing TrapperKeeper service. So if you've already defined one service, you can use this macro to just transparently and automatically get a remote version that you can then include in a bootstrap.cfg. All these examples are over just plain HTTP, but the library fully supports HTTPS, and it uses certificate whitelisting to manage the inter-service communication. And you can have a different whitelist per service that you expose from a given Jetty. So it's a pretty fine-grained authentication model. So here's an example of using the def remote service macro. So this is the same protocol up top that we saw earlier, the Meow service protocol. And so we can create the remote version by calling the def remote service macro with a service symbol. Again, this is what you refer to from a bootstrap.cfg. And then whatever service protocol you want to use to generate your new implementation, and then a list of functions. We're not doing anything interesting here. We only have one function to RPCify, but we could also pass options here in this form, which we're not doing in this example. Options like function retrying and timeouts and stuff like that. So on the TrapperKeeper application that's going to act as the RPC server, we'd have a configuration like this. So we're still just setting up one web server, but now it's called RPC, and it's running on a different port. And then down in the RPC config block, we list out the services that we're going to expose. In this case, it's just the Meow service. We tell the RPC service how to actually find the code you want to call. There's no automatic discovery here. And so this is like a programmer has to go and say, in the config file, this is exactly where the protocol is defined that I want you to use to call functions as the RPC server. On the TrapperKeeper application that's going to act as the RPC client, we have pretty much the same, we have the exact same shape of the config, but here we don't care about namespaces because all of our code will be executed remotely. We instead care about what endpoint to use. So here we're just referring to the endpoint that we just configured the Jetty and the server to listen to. So this is what our bootstrap.cfg looks like for the TK app that's acting as the client. So we're still starting up Jetty because we're going to accept HTTP calls. So we're including our Meow web service as well. But down at the bottom, you'll note that I've added a new service symbol here. I've added the remote Meow service. So on the client side, I no longer care what language things are going to come back in because that's up to the RPC server to decide. What I'm going to do is I'm going to call the exact same code. I'm not going to change my code at all. But TrapperKeeper, this implementation is going to ship my call over the wire for me. Over on the server, we're just starting up the bare minimum to run our RPC server. So that's the RPC server service, a Jetty. And here we actually pick what concrete Meow language we want. So here we're going to pick French on the server. So I'm going to actually do a quick demo. Which is, not the best idea in the world, but I'm going to go for it. So first what I'll do is start up a kind of standalone all-in-one TrapperKeeper app. So there's no RPC here. And these little scripts here, all these are, and I'll cat one real fast, these are just invocations of line run. So the scripts aren't doing anything special. It's just line run pointing at different bootstrap and config files. So I'll run the standalone one first. Ignore the line noise from line noise. Ha 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 ha. All right, and we'll do some curling, as cats like to do. Okay, so you'll see we've started up all of our services. Our service said bonjour to us, that's cool. And now we're listening at localhost 8080. So we'll curl that, sure enough, we get back a meow. So everything is normal. You see over here in the log output, we see handling request for caller world, and then we see meowing in French. So that's the HTTP API server accepting a request, and then our actual core service doing some meowing. So now what I'm going to do instead is run an RPC client TrapperKeeper application in this window here. And over here, I'm going to run a server. So you'll note on the client side, we no longer see the bonjour, I've initialized the meow service anymore. The only meow service we have on that side is just that thin remote call wrapper implementation. Whereas over on the server side, we see at the bottom of the log here, we're actually setting up the meow service. So let's go back up here. We'll curl again. We get the exact same result back. But now we see in the client application, there's that web request, and then over in the server application, the actual meowing is happening there. So now we can keep the web server TrapperKeeper application up and running. We can now, we only have to worry about starting and stopping the kind of server JVM to swap in implementations, which is a nice bonus. And like I said, we're now able to distribute that kind of computational load across different hosts. Kill these off. Cool. So we don't have to use my backup bootleg screenshots that I made just in case. Oh, that's right. I only selected one window. There we go. So some of the features that we're working on right now for this library is instead of, so we're already using a persistent HTTP client for each of these services to make their RPC calls. We're working instead on actual persistent connections. So what we're going to try to do, and this isn't done yet, I don't know if this will be viable, but we're looking at using SSL over WebSockets so that an RPC client service can just open a persistent connection to a server and just send function calls down the wire. And I'll note we're using message pack and transit as our serialization format, which has worked out really well for us. We want to add metric reporting, so every time you make an RPC call, you get some data back about how long it took, stuff like that. And then some of the things we want to add to the def remote service macro in terms of what it supports on the client side are things like I mentioned, function retrying, and some kind of transparent load balancing. We don't know the best way to architect that just yet. So that's all I have on the RPC library. Like I said, we demoed this just because we think it's an interesting thing that you can now do given this kind of split protocol and implementation paradigm. There are definitely other Clojure RPC libraries out there. This isn't really intended to replace those. This is an adaptation of the RPC model to Trapper Keeper specifically. So if you're fist shaky about why we didn't use some RPC library or another, just shake that fist right at me and tell me why I should use it, and we might totally use it under the hood. The important thing for us is this really nice Trapper Keeper interface and macro interface to doing this kind of stuff. That's all we've got. If you want to learn more about Trapper Keeper, we have really wonderful and extensive documentation up on a GitHub wiki, so you can check that out. The Meow service demo that we used throughout, that's also up on GitHub, as Ruth mentioned. So you can go poke around at that and see what we were doing. And the RPC library also is open source under the Puppet Labs namespace as well. We who use Trapper Keeper hang out on Freenode, so come say hello. We're really excited for people to use this framework and contribute. So yeah, come say hi. Thanks very much. Does anybody have any questions at all? I'm not sure how much time we have. Yeah. So the question was, do we have any support for dynamically reloading configs in the lifecycle functions? As far as I know, that is not a feature that exists right now. But it is definitely a useful feature. But yeah, it's not one that we currently support. Yeah. 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 So the question is, do you have to use line, or can you actually like make a jar and run that with Java? Absolutely. So that's how we deploy all of our stuff. So one of the things that we do with Trapper Keeper is we write services that are delivered on premise, and so we just compile jars, and then we ship those directly to customers, and then yeah, those are just running against Java. So yeah, we definitely support that. We're just using line for development. Yeah. So the question is, does the bootstrap file influence what gets compiled? That's a great question. It doesn't. So yeah, all the services are going to get compiled for sure. Yeah, the bootstrap file is just used at runtime by Trapper Keeper. Yeah, we don't do any kind of optimization like that. Yep.
How would you handle a case where a specific implementation needed some kind of extra config?
Yeah. So I'm pretty sure that falls under the kind of optional dependency kind of, or like the question is, what happens if one specific implementation just needs something that the other implementations don't? Is that kind of what you're asking? Yeah. That's not a case that really comes up that much for us. I don't have a great answer. Do you have any?
I guess I would say to that probably you could put that into the config file, and other implementations wouldn't use it, but the implementation that does need it can use it. Be probably my answer.
Yeah, one feature we're working on is optional dependencies. So I guess what you could do is, say, this service or this dependency that this one implementation has is optional for the other ones, and then model it that way. But that's one of the features we're currently working on. Anything else? Cool. Thank you all so much.